Now, honestly, this is the first question, which isn't bad actually, considering I started at 2020 and I'm into the 1960s, I think. It's the first question where I had to cheat. That is, I had to use a bit of computing power to figure out what to do. The first time I tried this, I wrote down two quadratics, multiplied them together, and compared the coefficients, but that didn't seem right. It was getting too complicated. Then the second time I tried this, I tried to guess one of the roots and use long division, but that also didn't work. And when I used the computer to solve this, I could see why it didn't work because none of the roots are integers. So looking at the answer, it made me realize that the only way this could be done is if you make an assumption. And I'm quite surprised that you have to make this assumption because there's nothing in the question that would lead you to think that this assumption is the assumption you need to make. That is, you need to assume that when they say it can be written as a product of two quadratics, one of the quadratics is like this, ax squared, or, well, just, you know, um, x squared plus, let's just call it a. And then the other quadratic is bx squared plus cx plus d. And it's interesting because recently I did a question like that where I did assume this or I did something like it, but there was enough information in the question to let me believe that these were the forms for the factors. So what they don't tell you here is that there's going to be two factors in the form of plus or minus alpha I, and then two other factors, or I should say, sorry, roots. Two roots in the form like this, and then two other roots in the form of, something like beta plus or minus gamma, or root gamma, two surds. So there's two surds and two purely imaginary numbers. But that's not given in the question. So unless I'm missing something that I've not seen before, then I wouldn't know how to do this without having to be told that the factors are written like this. So now that the factors are written like this, I can multiply it out and compare. So if I multiply this out, I get bx4 plus cx cubed plus dx squared plus abx squared plus acx plus ad. So that's going to be bx4 plus cx cubed plus ab plus dx squared plus acx plus ad. So you can see that b has to equal 2. C has to equal minus 1. And then if you look at this one, AC has to be minus 3. So that means A is 3. And then AD has to be minus 15. But you know that A is 3. So that means D has to be the negative 5 then. And that's it. It's so easy now once you knew to make that factorization in that form. Impossible otherwise. So now the factors are x squared plus 3 and then 2x squared minus x minus 5. So that means x is plus or minus I root 3 or minus b, which is plus 1 actually, plus or minus the square root of b squared, which is 1, minus 4ac 40 then. So yeah, plus 1 plus or minus root 41 all over 2a all over 4. So there you go. They're the four factors here, or the four roots I mean. So I factorized and I found the roots. That is fine. Now, well, it's not really fine. Now, the second part. They just want you to calculate the root of 8 plus 6i. So you could just say root 8 plus 6i equals a plus bi. You can square everything. So you get 8 plus 6i equals a squared plus 2abi minus b squared. So this means a squared minus b squared equals 8. And ab must equal 3, which means a equals 3 over b. You can put that in there. You get 9 over b squared minus b squared equals 8. If you multiply by b squared, you get 9 minus b power 4 equals 8b squared. So you get b power 4 plus 8b squared minus 9 equals 0. So that is b plus 9b minus 1 equals 0. So b equals 1 or 9, right? And then a is 3 over b. So that's 3 over 1 or, hang on, let me not get confused. B is 1 or 9 and a is 3 over b. So that's 3 over 1 or 3 over 9, 1 over 3. Interesting. So that means it's equal to a plus bi, 3 plus I, or 1 over 3 plus 9i. Now, I don't usually end up with fractions here, but if we square it out real quick, we can check. I'll just put that in green here. So just to check the answer. So squaring this out, that'd be 9 plus 6i minus 1. That's 8 plus 6i. Yep, that checks out. Okay, so the first one's definitely right. Okay, let's try the next one. So that's 1 over 9 plus... No, that's not going to work. I must have done something wrong here. A is 3 over b. 3 over 9. That is 1 over 3. Okay, if I square it out, 1 over 9 and then twice the first by the second, that's 6. I. Good. And then minus 81. Yeah, no, something's gone wrong there. Maybe I've done something stupid with my factorizing. Let's just check. 9 by minus 1 is minus 9. 9b minus 1b is 8b. So b is... B is 1 or minus 9. All right, I did screw up there. Okay, let's fix that. All right. So that's b minus plus 9, and then b minus 1 equals 0. 9. Yeah, so b equals minus 9 or b equals 1. So if b equals 1, a is 3. And if b equals minus 9, a is 3 over minus 9 minus 1 over 3. Still, I'm not happy about that. Something, that doesn't seem right. A is 3 over b. I feel like it's upside down. I must be doing something wrong that I can't see. A squared minus b squared equals 8. ab equals 3. A is 3 over b. I've subbed in the a. That's 9 over b squared minus b squared equals 8. And multiplied by b squared. That's 9 minus b4 equals 8b squared. That's b4 plus 8b squared minus 9. Okay. A plus bi minus 1/3 minus 9i, or 3 plus 1i. Why is my second answer not working here? Let me think about this. Okay, guys. Yep, I see exactly what my mistake is. I can't believe I didn't notice this sooner. When I was factorizing my quadratic, I forgot that it's not technically a quadratic. It's a b power 4. So these guys here should have been b squareds. So you get b squared equals minus 9, or b squared equals 1. So you reject that and you get b equals 1 or b equals minus 1, which means a would equal 3 or a equals minus 3. So the answer would be 3 plus I or minus 3 minus I. And that makes perfect sense because it's a square root. The answer should be in the form of plus or minus the primary answer. So yeah, that was silly of me. I just simply forgot to carry the squares down here, and that's what messed up the rest of the question. But it's all sorted now, and we have the right answer.